Hello and welcome. We will discuss PYQs of time, speed and distance in this video, and our theme is formula based problems. I hope you all are aware of the relation that exists between speed, distance and time. If you don't, please write it down. Let me write it for you. The formula or the relation between speed, distance and time is given by speed is equals to distance upon time. I have represented speed with the help of s, distance with the help of d and time with the help of t. Now, this is not only the way of using this formula or this relation, there are two more forms. Form number 2, you can replace s and t with each other. So, it becomes t is equals to distance upon time. So, if you have the value of distance and the value of time and you want to calculate speed, then this first form will be utilized. If distance and speed are known to us, then and we want to find out time, this second form should be utilized. And the third is distance is given by speed into time. So if you know the speed and you know the time and you want to find out distance, then this third form should be utilized. Okay, and these are just the way of representing thing. You can keep one formula in your head and you can draw the remaining scenarios in the paper also. Okay, apart from this, there are few more points that I want you to keep in your head, and those points are, just a second. Point number 4, when remember, when distance traveled in two different cases is same or constant, right? In that case, ratio of speed will be inversely proportional to ratio of time taken, where s1 and s2 are the speeds for two different scenarios, and t2 and t1 are the time taken by a particular vehicle or person or an object in those two different scenarios respectively. Okay, so remember, if distance is constant, then ratio of speed is inversely proportional to ratio of time. Point number 5, if distance is constant or distance is discussed, distance constant has been discussed. Okay, now suppose speed in two different scenarios remains same or remains constant. Speeds in two different scenarios remains same or remains constant. In that particular case, ratio of time taken in those two scenarios will be directly proportional to ratio of distances covered, right? If speed is same, more is the time, more distance will be covered by an object or or a vehicle. Okay, now case number 6 or point number 6, see, distance same we have discussed, speed same we have discussed. Now one more point, and important one, is when time taken by a vehicle in two different scenarios are same. So time is equals to, just a second, yes, time taken is same or constant. So in this case, ratio of speed will be equal to ratio of the distances covered. Meaningly, if time taken is same, then more speed corresponds to more distance traveled. So these are the few scenarios that we will use while dealing with the question of time, speed and distance. I hope this is clear to you. If you want to make a note of it, kindly pause the video, note it down. Okay, now let's move on. This is the question. It says a person X from a place A and another person Y from a place B set out at the same time to walk towards each other. Okay, so let's say there is a place A and then there is one more place B, from place A, X has started its journey, and from place B, Y has started its journey, and they are traveling towards each other. Okay. Now, what happened? Next statement is they have started at the same time. At the same time. So let's say X has started its journey at 9 a.m. from point A. Then Y will start its journey from B at 9 a.m. Then next statement is the places are separated by a distance of 15 kilometers. Distance between this station A and this station B, or place A and place B, is what? It is 15 kilometers given to us. Next is X walks with a uniform speed of 1.5 kilometer. So speed of X is given to us. It is constant throughout and its speed is 1.5 kilometer. And Y walks with a uniform speed of 1 kilometer per hour in the first hour, with uniform speed of 1.25 kilometer in the second hour, and 1.5 kilometer in the third hour, and so on. Okay, so speed of B or speed of Y is changing after every hour. Okay, keep this in your mind. Next is which of the following is or are correct? Statement 1. They take 5 hours to meet. So let's verify this statement. Okay. They take 5 hours to meet. It means after 5 hours we should know the distance traveled by X and distance traveled by Y also. Speed of X is given to us. And as per statement 1, time taken by X should be 5 hours. So let's find out the distance covered by X. We know that distance is given by speed into time. So if we want to find out distance covered by X, we must write down speed of X into time taken by X. As per statement 1, time taken by X is what? 5 hours. And it comes out to be equal to what? 7.5 kilometers. So from the beginning till 5th hour or till the end of 5th hour, total distance covered by X will be what? It will be 7.5 kilometers. So X was here, right, from point A. So X will cover 7.5 kilometers. 7.5 kilometers after 5 hours. So I can see after 5 hours, X will be midway between X, A and B. As per this calculation, I can say X will be in the midway between A and B. This is the scenario of X after 5 hours from the very beginning. Let's talk about Y now. I can see Y is not traveling with uniform speed. Y is changing its speed after every 1 hour. Okay. So if I talk about very first hour meaningly we have started from 9 a.m. So 9 till 10. 9 till 10, this speed of Y is 1. 9 till 10, speed of Y is 1 kilometer per hour. And 9 till 10, distance traveled, time taken by Y is what? 1. So distance traveled by Y from 9 till 10 in the very first hour will be 1 kilometer only. It will be what? 1 kilometer only. Similarly, if we want to talk about second hour meaningly from 10 to 11. From 10 to 11 and throughout the second hour, his speed was 1.25 kilometer. So distance traveled by him will be 1.25 into 1. Why 1? Because from 10 to 11, 10 to 11 is the duration of 1 hour. Speed into time will give me the distance. So distance traveled by y in the second hour will be 1.25. Similarly, in every hour, he is increasing his speed. So distance traveled by y in the third hour will become 1.5. Distance traveled by y in the fourth hour will become 1.75. And distance traveled by y in the fifth hour should be what? 2. Okay. Now, in 5 hours, total distance traveled by y, if we add them, it comes out to be equal to what? It will be 7.5 kilometer. Okay, see, 1 3 4 5 2 7. Okay, 25 and 5 75, or it becomes 5 4 to 6 and 7.5 it is. You can cross check if we add. Okay, now it means from the very beginning, after 5 hours, y will be cover 7.5 kilometer, right? So after 5 hours, y will also be in the middle of A and B. So which, see, after 5 hours, x is also in the middle of A and B, and y is also in the middle of A and B. So definitely they meet. Statement number 1 is true. Similarly, second statement says they meet midway between A and B. This is also true, because total distance was 15 kilometer, and everyone from the beginning, everyone, whether we talk about x or we talk about y, they are covering how much distance? They are covering 7.5 kilometer. 7.5 is the mid value of 15 kilometer. Hence, second statement is also correct. Answer should be option C. I hope, guys, this is clear to everyone. Please make a note of it. Okay, let's move on. Next statement is a train travels at a certain average speed for a distance of 63 kilometer. So distance in the first scenario is 63 kilometer, and then travels at a distance of 72 kilometer. And in the second scenario, he is covering how much? He is covering, that train is covering, sorry, not he, that train is covering 72 kilometer. Next statement is at an average speed of 6 kilometer per hour more than its original speed. So let's say originally the train was covering, or the average speed of train was x kilometer per hour. So this distance of 63 kilometer has been covered by that train at this speed, which is x kilometer per hour, and this distance of 72 kilometer has been covered by that same train at a average speed of 6 kilometer more than its original speed. So x plus 6, which comes out to be equal to x plus 6 kilometer per hour. If it takes 3 hours to complete the total journey, what is the original speed of the train in kilometer per hour? Okay. Now, guys, listen. Distance is 63 kilometer, speed is x kilometer per hour. So, time taken to cover this distance 63 will be distance upon speed. Okay. Plus, distance was 72 kilometer, distance and speed was x plus 6 kilometer per hour. So distance upon speed will give me another time. So this 72 upon x plus 6 is the time taken by that train to travel 72 kilometer. Now, time taken to travel 63 kilometer plus time taken to travel 72 kilometer must be equal to 3, because it is given us. So in 3 hours to complete the total journey. So total journey was 63 plus 72. So total time should be 63 upon x plus 72 upon x plus 6. Now there are two ways of dealing with this kind of scenario. Either you can solve this question by using quadratic equation, but solving this question by quadratic equation will become a very tedious task. Rather than that, try solving this kind of equation through options. In the option, the value of original speed is given and we have assumed original speed to be x. So in the option, values of x is given. So let me pick that option with which I can cancel out the 63 and 72 easily. So let's go for this 42. So if you assume x to be 42, so 63 upon 42 plus 72 upon 42 plus 6 is 48. Let's solve this. So 7 nines are 63, 7 6s are 42, 3 3s are 9, 3 2s are 6. Okay, let's cancel. 24 2s are 48 and 24 3s are 3 by 2 and 3 by 2 is what? 3. So if I assume x to be equal to x, then x to be equal to 42, then left hand side of this equation and right hand side of this equation becomes equals to each other. Hence value of x or the original speed is what? It is 42 km per hour. Hence option C is the right choice. Kindly make a note of it.